Scientists reveal how to travel faster than the speed of light. Ever pondered whether you could beat the speed of light? In the end, it might not be that far off from reality. You wonder how? It's just a warp drive, basically. Adding to it, a recent study suggests that going faster than light may be possible by taking advantage of a loophole in general relativity, which refers to laws of gravitation proposed by Albert Einstein. Historically, scientists have discouraged others from taking the idea of warp drives too seriously, but theoretically, the concept is sound, and the benefits are too paramount to dismiss only to the science fiction silver screen. So, here are more revelations on how to travel faster than the speed of light. Welcome back to Space Infinity. The idea of a warp drive is quite straightforward. The speed of light is the dominant force in space, and the only thing that can dominate it is space-time. The goal of warping space-time around an object is to develop warp drive. In order to move an object faster than the speed of light, one basically needs to spiral it into a negative energy machine. Space and time behind the spacecraft would enlarge as a result, while those in front of it would contract. Mexican scientist Miguel Alcubierre first had this idea in 1994. However, there is a catch. Negative energy is not permitted by the principles of physics, even though summoning evil energy is not wholly impossible. According to scientists, energy would have to be taken out of a vacuum in order to do this. Theoretically, this would pave the door for negative mass and negative gravity, basically the polar opposite of what we currently feel. Even so, the theoretical fixation on effective warp drive persists. Many people still think that warp drives could not be physically feasible. However, astrophysicist Alexei Bobrik of Lund University told ZME Science, "This is no longer true." Researchers in Sweden are currently trying to make warp drive a reality. How, do you ask? Simply by avoiding the need for negative energy and basing the research on physical concepts now known to humanity. Dr. Eric Lenz, a physicist at the University of Göttingen in Germany, has discovered ways to travel faster than light by constructing new kinds of space-time bubbles around a spaceship. By delving further into Einstein's difficult theory, they are referred to as solitons, and are the same as Dr. Alcubierre's ideas. Importantly though, Dr. Lenz has found that some of these bubbles may be created using common materials. According to Dr. Lenz, this is the first known solution of its kind. He published his discovery in the journal Classical and Quantum Gravity. His calculations revealed that the trick of warping space-time around a spaceship may be accomplished by a common sort of matter known as plasma, a kind of gas with positive and negative charges. Danish astronomer Ole Romer determined that light moves at a finite speed in 1676 by observing the motion of Jupiter's moon Io. The American Museum of Natural History in New York City claims drawing on Romer's results. Dutch mathematician and physicist Christian Huygens made the first effort to measure the true speed of light. We now know that the speed of light in the vacuum of empty space is approximately 186,282 miles per second, or 299,792 kilometers per second. So Huygens' estimate of 131,000 miles per second, or 211,000 kilometers per second, is not accurate by today's standards. However, his assessment demonstrated that light travels at an incredible speed. In a vacuum, nothing in the cosmos can move faster than light, according to Albert Einstein's theory of special relativity. Jason Casabry, an associate professor of aerospace engineering at the Propulsion Research Center, University of Alabama in Huntsville, said that humans cannot travel across space faster than the speed of light. In a non-vacuum environment at least, the adage, "nothing can go faster than the speed of light," isn't completely true, according to Claudia de Rham, a theoretical physicist at Imperial College London. She added that there are some limitations to take into account. Light can be thought of as both a wave and a particle, since it possesses both wave and particle-like qualities. We call this wave-particle duality. According to de Rham, if we consider light to be a wave, there are many reasons why some waves can go through a medium more quickly than white or colorless light. She cited the fact that when light travels through a material, such as glass or water droplets, the different frequencies or hues of light travel at different speeds, as one such explanation. According to a blog article by the University of Wisconsin-Madison, rainbows are the clearest visual example of this, since they often feature the long, faster red wavelengths at the top and the short, slower violet wavelengths at the bottom. The same is not true, though, when light moves in a vacuum. According to Rhett Allain, a physics professor at Southeastern Louisiana University, all light is a sort of electromagnetic wave, and they all have the same speed in a vacuum of 3 × 108 meters per second. This indicates that both radio waves and gamma waves have the same speed. Thus, somewhat strangely, de Rham claims that the only thing that can travel faster than the speed of light is light itself, but only when it is not in the vacuum of space. It is interesting to note that light will never travel faster than 186,282 miles per second, regardless of the medium. Evidence that fundamental particles known as neutrinos can move faster than light has been revealed by an Italian experiment. The finding would challenge the most fundamental principle of contemporary physics, that nothing goes faster than 299,792,458 meters per second, despite the caution of other experts toward the conclusion. The OPERA, or the Oscillation Project with Emulsion Tracking Apparatus experiment, is located 1,400 meters below Earth in Italy's Gran Sasso National Laboratory. It is intended to investigate a neutrino beam originating from CERN, the top high-energy physics research facility in Europe, which is located 730 kilometers away, close to Geneva, Switzerland. Fundamental particles known as neutrinos have an extremely low mass, are electrically neutral, and seldom interact with other types of matter. But they are all around us. As a byproduct of nuclear events, the Sun generates billions of neutrinos that pass past your eye every second. The latest finding is straightforward. The neutrinos are arriving 60 nanoseconds quicker than the speed of light permits. The 1,800-ton OPERA detector is a complicated arrangement of electronics and photographic emulsion plates. Antonio Ereditato, a physicist at the University of Bern in Switzerland and a representative for OPERA, declares, "We are stunned." The cornerstone of Albert Einstein's special theory of relativity, which itself is the basis of modern physics, is the notion that nothing can move faster than light in a vacuum. One of science's most fundamental presumptions, that the laws of physics are the same for all observers, would be disproved if neutrinos were moving faster than the speed of light. John Ellis, a theoretical physicist at CERN, states that, if it's true, then it's very exceptional. Ereditato claims he is secure enough in the fresh finding to make it public. The 730-kilometer distance between CERN and its detector, according to the experts, was precisely measured to within 20 centimeters. They have observed the impact in more than 16,000 incidents measured over the previous 2 years and can pinpoint the travel time to within 10 nanoseconds. Given all this, they think the outcome has a 6 sigma significance, which is physics speak for absolutely correct. On September 23rd, the team will present its findings at CERN, and a preprint of those findings will be published on the physics website arxiv.org. Similar results have been observed in at least one additional experiment, though with much lower confidence. Neutrinos from the Illinois Particle Physics Facility, Fermilab, arrived a little early at the Main Injector Neutrino Oscillation Search (MINOS) experiment in Minnesota. According to Jenny Thomas, a spokesperson for the experiment, the MINOS team first downplayed the discovery in part because there was too much uncertainty surrounding the detector's precise location to be certain of its relevance. Thomas claims that prior to the most recent OPERA result, MINOS was already preparing more precise follow-up studies. "I'm hoping we can start that and make a measurement in the next year or two," she says. The claim that Einstein demonstrated that nothing could move at or faster than the speed of light is untrue. He demonstrated that this maximum speed limit, 300,000 kph or almost 1 billion kph, only holds true provided space and time are not altered in any manner. According to Einstein's equations, there is no upper limit to how quickly we could travel around the galaxy if space-time were to be bent around a spacecraft. Breaking the speed of light has always been a fantasy, only being accomplished by characters in science fiction television programs. However, a flurry of recent discoveries on the nature of space and time indicate that Einstein's purportedly unbreakable speed limit might not be as unbreakable as previously thought. What are your thoughts on this? Let us know what you think in the comments. Smack that like and subscribe button. Then head to the Space Infinity archives for more cosmological revelations.